Okay, here is unit circle part 2, where we are dealing with angles that are greater than 90 degrees, and we're still going to use the same situation to figure out the sine and cosine of those angles. So, first example is 150 degrees. So you know that 150 is more than 90, and our angle always starts from here and then goes in this direction. So we could say that's 90 degrees. We could say this one, 180 degrees, 270, and then all the way back to 360. So that's like this. 90 degrees to here, 180 degrees to here, 270 degrees to here, and 360 degrees to here. So when you have something like 150 degrees, you have to figure out, sure, it's more than 90, but how much more? So 90 plus 60 gives us 150. So you can think about this two ways. I'll kind of zoom in. For a 150 degree angle, this little guy, or this guy, so this guy's 60, and this little guy would be 30 degrees. This we call our reference angle. And reference angle is how far away is the angle from the x-axis. So we're not really going to use that 60, but that's a way to think about 150 is 90 degrees plus 60 degrees. So our little reference angle is 30 degrees, and like we did in the previous lesson, we always, from our terminal point, drop a line to the x-axis, and voila, there we have a triangle. So hopefully you recognize this right triangle as a 30, 60, 90, right? Not a 45, 45, 90. So we got a 30, 60, 90 triangle. We know this is the unit circle. The hypotenuse is always 1. The short side, so you have to recognize this as the short side. Okay, short side is 1/2, and the long side is root 3 over 2. So from the previous lesson, we got that the cosine of the angle is the x-coordinate of our terminal point, and the sine of the angle is the y-coordinate of our terminal point. Now, we deal with positives and negatives, so let's just refresh our memory. Remember that, alright, xy coordinate system, right? We're very familiar with that. And again, here's our unit circle. So keep in mind that if we're talking about a point, I'll zoom in even further, keep in mind that if we talk about a point over here, right, our x-coordinate is negative and our y-coordinate is positive. I'll say that again. Our x-coordinate is negative and our y-coordinate is positive for a point over here. If we had a point over here, let's see, x-coordinate negative, y-coordinate negative. If we had a point over here, x-coordinate is positive, y-coordinate is negative. So I'm just going to write these because this will come up. So in this case, x-coordinate is positive, y-coordinate is negative. In our red dot, we had the x-coordinate being negative and the y-coordinate being negative. And for our blue dot up here, the x-coordinate was negative and the y-coordinate was positive. So you have to take that into consideration when saying or when figuring out what the value of sine or cosine is. So when we look back here, we got all our information on screen, kind of. Looks to me like our x-coordinate is negative root 3 over 2. So, yep, you guessed it, cosine of 150 degrees is negative root 3 over 2. Check your calculator, it's going to agree. The sine of 150 degrees, let's take a look at our y-coordinate. Looks like a positive 1/2. And so the sine of 150 degrees is positive 1/2. Boom. Yep, you can do it. No calculator necessary. So that's our first example of an angle greater than 90 degrees. Let us proceed. Next up, 225. So let's pretend you're not even looking at that. And the question just says 225 degrees, what's the sine and what's the cosine? So we know we're going to draw it, and you can think, all right, let's see, 90, 180, and let's see, how many do I have left? Oh, another 45 to go. So it's going to be something like that. Let's see if I do that. Oh, nice. All right. So, again, angle always starts here. And we're imagining this line rotating around here. So, rotates up to 90, and then 180. And then another 45 degrees. So, what we're interested in is, let's see if I can, oh yeah, get out of there. So what we're interested in is our reference angle, which is this. So this little guy here, again, 225 is 45 degrees more than 180. So here's our terminal point. Looks like our x-coordinate is going to have a negative value, and our y-coordinate is going to have a negative value. We drop a line to the x-axis, forming our little triangle. And we recognize that as a 45, 45, 90. Therefore, hypotenuse is 1, root 2 over 2, and root 2 over 2 as the lengths of our sides. So for 225 degrees, we can say cosine of 225 degrees equals the x-coordinate of this point, which is negative root 2 over 2. Sine of 225 degrees, little degreesers right there, is the y-coordinate of this point, which is what? Negative root 2 over 2. Yep, that's it. Let's try another example. Okay, 300 degrees. And it's not drawn for us. Good. So you should try this. You're sitting there in front of the computer, put it on pause, and see if you can draw where the 300 degree angle is. Yep, just waiting. Try to draw it. Okay, so here's 0 degrees. We go 90. We go 180. 270. And how many more is left? Yep, 30 more degrees. So when you're drawing these, you should actually kind of think about it. I mean, obviously you're thinking about it, but where you draw your line, so if I were like, oh, it's a little more than 270, and I drew this, that's going to kind of mess me up, because this is not to scale. This is not 30 degrees, right? If this is 90, this is not 30. And when you go to draw your triangle, you're going to be messed up, because from the triangle you draw, you have to figure out, is that a 30, 60, 90, or a 45, 45, 90? And if it's a 30, 60, 90, which is the 30 and which is the 60, what's the short side and long side? So that's obviously wrong. We go 90, 180, 270, and then another 30. So think, right? See how I split that up into thirds? So 30 degrees. Approximately, right? You're not measuring this, but it has to be ballpark. Because you can see I'm going to have this triangle here like this, and it's obvious what the long side is and the short side is. Whereas if I had drawn it over here, I'd mess myself up, and we don't like that. So there is my terminal point. We know this is 300 degree angle. We're going to, from the terminal point, drop a line to the x-axis, make our right triangle, figure out what kind it is. Looks like a 30, 60, 90, right? And in the 30, 60, 90, hypotenuse is 1, short side is 1/2, long side root 3 over 2, and now we can just write it out. So let's see. Cosine of 300 degrees. So again, cosine, x-coordinate of this point, and because this is in the positive direction, not the negative direction, it is a positive 1/2. So yes, the cosine of 300 degrees is 1/2, and the sine of 300 degrees is, drum roll, yep, negative root 3 over 2. Negative root 3 over 2. So, yeah, I know I keep saying ask the calculator. Is that it? Yes, that's it. But you should ask the calculator if you don't believe me. So, alright, here we go. Sine 120, cosine 120. So, ideally you'll get to the point where you just kind of do this in your head. You picture the circle, but, when you're starting out, you're going to draw the circle. So, this is your question. You draw a circle, divide it up into the 4 quadrants, know that the angle starts here, and then think it through. Let's see, 90 degrees plus 30 more, right? Not 30 more, or not 30 more, not in the middle, but 30 more. So we're going to draw that. See how that 90 degrees right here is split up into thirds, right? So where were we? Right here. All right. So there's a 120 degree angle. That, if we zoom in, we can look at our reference angle. So here's our reference angle. Here is our triangle. Right triangle, we know the hypotenuse is 1, short side is 1/2, long side root 3 over 2, because this is a 30, 60, 90. And we're looking for the sine and cosine 120 degrees, so cosine of 120 degrees is the x-coordinate. X-coordinate, notice how this is going to the left, so it is a negative. So it's negative 1/2, and the sine of 120 degrees, y-coordinate, this goes up, this is positive root 3 over 2. Very good. So I think from here on out you're going to be drawing your own circles and triangles. You can do it. Oh, alright. Some practice. So you should now be able to do this on your own. There we go, where it's laid out for us. These are the different angles we're looking at, and we're going to find the cosine and the sine and the cosine and the sine, etc., etc., etc. So put this on pause and write them down and figure them out. You'll probably draw circles for all of them. And then in a moment, I will tell you the answers. So hopefully you have now figured these out. If you're just sitting there passively watching, shame on you. For 45 degrees, so I'm just going to go quick. 45 degrees is right here. So we have positive root 2 over 2 and positive root 2 over 2. 180 degrees is right here. So the cosine is negative 1 and the sine is 0. Again, when we're right on the points, right, with coordinates of 1, 0, or negative 1, there's no triangle necessary. 120 degrees, that's 30 more than 90. So it'd be like this. So it looks like our cosine is negative 1/2 and our sine is root 3 over 2. 270 is right here. 270. So it looks like we have an x-coordinate of 0, y-coordinate of negative 1. So cosine is 0 and sine of 270 degrees is negative 1. Woo! Doing it. Alright, 315. Aye, where does that go? So let's see. We got 90, 180, 270. Oh yeah, I see it. 270 plus 45 would be 315. Hey, so that is right there. Yeah, right in the middle. So we have a 45, 45, 90. Looks like our x-coordinate is positive, y-coordinate is negative. So cosine root 2 over 2 and sine negative root 2 over 2. And again, I'm going quickly through this because you've already solved these and we're just checking our answers here. 210. We got 90, 180 plus another 30 So here's our, that's a 30-degree angle in there as our reference angle, 210. So it looks like our cosine would be negative. It goes to the left, root 3 over 2, the long side. And our sine is a negative 1/2. 150 degrees is, let's see, 90, 180, so it's 30 less than 180, so it'd be right here. Our cosine is again negative, root 3 over 2, and our sine would be a positive 1/2. And lastly, but not leastly, if that's a word, 300 degrees, 90, 180, 270, 270 plus another 30. So we got our little triangle here. Looks like a 30, 60, 90. So our cosine, that looks like a positive 1/2, the short side of the triangle, and the sine, a negative root 3 over 2. That's the y coordinate of our terminal point. So check your answers. If you didn't get that, you could look back over the videos or ask me for lots of practice, and I got it. But I think those answers are right. So thanks for listening.